Building audience right now as we get ready for this morning's weather school. Have another great topic today. I think a lot of folks are really going to enjoy. I certainly hope so. That's the reason we're doing it. Talking to kids of all ages about weather and different types of elements of weather phenomena. Today we are going to talk about the enhanced Fujita scale, how we rate tornadoes, what makes tornadoes different from like a microburst type of a damage pattern, all that stuff coming up here in just a moment. My name is Craig Muller. I am a meteorologist, certified broadcast meteorologist by the American Meteorological Society. And one of the things I really enjoy doing is talking to the kids. So we'll get this one started here in just a moment. I know our board is up. I want to make sure I can see your comments and questions coming in. And again, it is just awesome to have everybody with us each and every morning as we talk about weather and different lessons for the kiddos. Why don't we go ahead and reveal the camera? Here I am in our 13 News Now studios. All truth, okay? Full disclosure, I'm wide open, all right? I'm wearing a coat today. Typically, I take off the coat and roll up the sleeves. I forgot my belt this morning. I was out the door so quick, and I was like, yeah, that's kind of sloppy, so we're doing the coat a little bit sharper look, and I hope you guys forgive me. Honestly, if I were going to take a survey right now, and I can see your comments coming in, if you are wearing pajamas, still, if you're in your pajamas right now, give me a thumbs up, okay? Give me a thumbs up if you're very casual right now. Maybe the kids they got the laptop out or they've got an iPad or an iPhone or something they're watching, and it's a little casual, all right? I know I'm not the only one that's not wearing a belt right now. I'm sure there's some of you guys getting some laughing emojis and a few hearts out there. But you know what? It's casual. It's good. So many of us are in right now as we're dealing with this nasty coronavirus and the crud that's out there. I'm glad you're here with us this morning. And again, we're going to talk weather. So if you're just now tuning in, my name is Craig Muller. I should really introduce myself. I'm a meteorologist. And again, I've been in the television broadcast business for a long time. It's hard to believe. I started back in 1989 and I was really young, almost too young to be on TV, but I did start as a wee lad, and I've been doing this for 30 years now, 31 years. This is something else. So when I'm not on TV, I love to teach weather and talk to kids in particular, go out school visits and do this. So that's what we're doing right now. We're talking about the EF scale. Now, how many of you have even heard of the EF scale? You know, we talk about the Saffir-Simpson scale when we talk about hurricanes and how strong those are. But the EF scale is designed to talk about the intensity of tornadoes. So with all the coverage of tornadoes, when we get into the severe storm season, you've probably heard, oh, it was an EF1 or an EF2 or 3 or 0 or 5 or whatever. We're going to talk about what all those numbers mean and why we use it. So this is going to be the topic this morning, and we'll start off with a look at what we were doing yesterday, just briefly talking about microbursts and how these cold tops of these thunderstorms collapse. Sometimes they come crashing down and that air rushes out, and you can have a lot of tree damage. But it's important to remember what we were talking about yesterday. With a microburst, the trees tend to all lay in one direction. The winds rush out in a single direction. With tornadoes, it's different, okay? Here's what you get. With a tornado, you get a more chaotic pattern. And this is an aerial picture of damage in Moore, Oklahoma. This is taken by the U.S. Air Force. They had a base out there and they were helping with recovery and cleanup efforts, and this is one of the aerial shots that they took. But you can see the damage here, just incredible. I mean, there are cars thrown around, and this is an image here where, you know, these cars that are parked on the street, this is after the tornado is gone, obviously, but you can see there's some cars that were thrown around into houses. You've got this edges of this path where there's some damage, but the center of this path completely destroyed homes. So we're going to talk about how we rate these things and what makes this so much different. Let's start off with surveying tornado damage. And I've talked with a number of Weather Service science coordinators and the folks that go out and survey tornado damages. I've talked to them here in Southeast Virginia, and we had a great crew that would go out back in St. Louis when I was a chief meteorologist at KSDK. I would talk with those guys about what they look for and when they go out and survey the damage. So overall, you look for a few things. Now, I mentioned with the microbursts, all the trees or all the damage typically kind of in one direction. It may fan out a little bit. Okay, kind of fan out that way, but everything pretty much going in the same direction. With a tornado, you look for a more chaotic fall pattern. You might see large trees not all laying in the same direction, but maybe crisscrossing and kind of twisting around a little bit, all right? You look for a clear path boundary, edges on that tornado path. If it's going to be on the ground for a little bit, you could say, hey, this tornado was this wide because we see one edge of it here and one edge of the path there, and it's very clear, versus gradually fanning out. Does that make sense? Clear edges, okay? And then the other thing, sometimes there are random signs of excessive force, and it's kind of hard to quantify that because you get with straight line winds, you can have a lot of damage, excessive force. I mean, huge trees toppled, cars or trucks knocked over with thunderstorm microburst outflow. You can get that, okay? But with tornadoes, it seems to be more random. You might have a straw or a stick stuck into the side of a house, and there might be something very close to it that's hardly touched. It's more hit and miss. It's more chaotic and more random. So those are some of the things that they look for when they go out and say, okay, was this just thunderstorm outflow? Was this just wind damage? Or was there a tornado? Now, a lot of times, thanks to our improved radar technology, which we also talked about in a previous weather school, we have a very clear indication on the radar that there was a circulation, a rotation, and all you have to do is match up that rotation with some of these other things we see on the ground, and you can confirm that there was a tornado. Wanted to show you a couple of satellite images, and this is great stuff. NASA has these satellites up, numerous satellites that take a look and survey the Earth and can get really detailed. There's a little scar right here. I don't know if you can make it out, just a little white patch right here. Okay, going into Oklahoma City, this was a little scar from a tornado that had touched down here, okay? I'm going to show you one that was on the ground for a much longer time. This tornado track, this scar pattern, was in western Massachusetts, and look at how long this thing goes. This is just part of it, okay? It was on the ground for 39 miles, but you can see this part captured again by a NASA satellite. You can see that tornado track very, very clearly on that image. It's crazy, isn't it? Almost looks like a road or like a river valley or something, but that was just a tornado that touched down, what we call a long duration tornado. Sometimes they just touch down and then they spin right back up and they do those, almost dropped my clicker, quick hands. Anyway, sometimes they touch down and they bounce back up. Other times they can go down on the ground and stay on the ground for miles and miles and miles. We call those long duration tornadoes. Those are really, really troublesome. And when I was back in St. Louis, we had one down in Perry County that went on to move across the river into Illinois, and that same complex extended all the way into Indiana. So really incredible tornadoes, some of them. Now this image, okay, again, taken by a NASA satellite. They were looking at thermal imaging here. This is Joplin, and there was a really bad tornado, huge tornado that struck Joplin, Missouri, and this is the scar pattern as it was picked up from this thermal imaging. But you can see again how it really got broad and took out a large area going into Joplin. So some different images here from outer space. Now, we're going to talk about the Fujita scale. We talked about that, and really specifically the EF scale. That's the enhanced Fujita scale. And for the kids, again, watching, I want you to think about this now, okay? There was a professor, okay, Dr. Ted Fujita, and he developed this scale, the original Fujita scale, developed back in 1971. We'd have these tornadoes and there'd be damage, but they said, we need to keep track. Are these intense? Are they weaker tornadoes? What's going on here? So he put together this scale, all right, and he started in 1971. It rated tornadoes from F0 to F5 based largely on the damage intensity that they were seeing. All right, we no longer use that, okay? It was changed from the original Fujita scale to what we call the enhanced Fujita scale. And there's a picture of Dr. Ted Fujita. He passed away back in 1998. All right, so let me ask you a question, and I got to tell you, Rochelle Peart, who I think is in the chat room right now. Yeah, Rochelle's in there. Okay, thank you so much. Rochelle can answer some of your questions, and I'm sure she's interacting with you. Peyton may be in there. I know Peyton sometimes jumps in on these as well. You have this trivia question. Rochelle put this together, and she stumped me. All right, I'm pretty sharp on this stuff, but she got me on this one, truth be told. First, I tell you I'm not wearing a belt. Now I tell you I blew this trivia question. But here's the question. When did the enhanced Fujita scale go into effect? Was it in 2000, 2007, 1992, or 1971? Now, we just talked about the original, the F scale, the Fujita scale, okay? And we said that was invented in 1991. So you know it's not going to be D, all right? So when did the enhanced Fujita scale go into effect? And I remember the big deal, and we were talking about it. I just got the date wrong. I couldn't remember exactly when. Like I said, I've been doing this for 31 years, so I got it wrong. So here's your options. You think it was 92, 2007, or 2000? Let's see if you guys have some guesses. I'm seeing some B's. I see a C there back in 92. Well, okay, you guys are pretty much looking like you're split between B and C. Okay, Yvonne's going with A. Adam's all about C. He's into it. Adam Moore saying, I think it's C. All right. Well, you guys, let me reveal the answer. The answer was 2007. I actually thought it was 2000. I couldn't remember exactly, but 2007 is when we went with the enhanced Fujita scale. So let's talk about that. All right, the enhanced Fujita scale implemented in 2007. It rates tornadoes based on the estimated winds and the damage. So what they started to do is say, okay, we have these structures, they're being damaged. Now let's try to put some winds, not just talk about, you know, this was F4 because this many buildings were destroyed. Now they're saying, okay, we're seeing this more specific type of damage. These are the types of winds that it takes to do that damage. So they really enhanced what Dr. Fujita had originally set up. And you can see we do use a list of damage indicators to estimate the tornado strength. So let's go ahead and show you the scale, and I'm going to show you the winds that we typically associate with the enhanced Fujita scale here. So you see EF0, EF5 is the strongest on the scale. It's those 6 levels, okay? EF0, 65 to 85 mile per hour winds. Sometimes you have even weaker vortexes. They're not really tornadoes, but you can get like a little thermal updraft. You might see a little whirlwind. I used to coach baseball, and out on the ball field every once in a while when it was really warm, you might get a little wind that would come and kick up, and some of the hot baseball dirt, infield dirt, might swirl up. We'd see like a little, almost like a dustnado or a little, you know, gustnado, something like that. Nowhere near this strong with the winds. They might kick around. The kids might get some dirt in their eyes, go, it stings or whatever, but not nearly that strong. EF0, basically 65 to up to 85 mile per hour winds. And you think about it, okay, you're looking at Category 1 hurricane force winds there. So the smallest tornadoes are comparable in wind speed to a strong tropical storm or a weak hurricane. And by the way, we're going to do some of these weather schools on hurricanes and tropical weather in the coming weeks, so stay tuned for more on that. All right, in EF1, 86 to 110 miles per hour. EF2, 111 to 135. Okay, think about this now. EF3, 136 to 165 miles per hour. Now you're getting in, when you get into that upper range of that 165, now you're talking about really powerful hurricanes like Category 5 hurricanes. So it's really, really incredible how strong these tornadoes get. More wind speed with the stronger tornadoes and hurricanes, but obviously hurricanes much larger area. Tornadoes are more concentrated. All right, so that's an EF3, 136 to 165 miles per hour. EF4, 106 to 200, and if that's not enough, we can get some over 200 mile per hour winds. Those are EF5s. So that's the scale. Now, how does the National Weather Service go out and rate these things? Here you go. And I want to give a big shout out again to our friends at the St. Louis National Weather Service. I was shared some of these images by one of the guys that goes around and talks to storm spotters. And we did this big event every year, Weather Day at Bush, and they shared some of these images. But they're so good for education. That's why I'm sharing these with you now. So you take a look, you say, okay, an EF0, okay, has very minor damage. Again, this is that smaller tornado, okay? Smallest on the EF scale. Minor damage. There could be some damage to some shingles, maybe a little bit of roof damage, or some gutters could be damaged. Could be a little bit of siding damage. But the structure of the house is good. You can see the windows are intact. You didn't have all the windows blow out. You didn't have doors ripped off. Okay, there might be a few branches broken on trees, but it's not too bad. So that, I mean, you wouldn't want to have to fix up your house, but when you consider a tornado coming through, that's not a lot of damage. That's an EF0. All right, and I'm seeing you guys. I'm assuming some of you guys may have some questions. Hopefully, you're able to answer some of those. And like I said, Rochelle's in there. I'll try to check it every once in a while. I appreciate all the likes and hearts. And hopefully, you're sharing this with your Facebook friends as well, trying to get more students out there able to see this and enjoy these weather schools. All right, fast facts. Confirmed tornadoes with no reported damage. Sometimes these happen in open fields, or there's just not a lot to really rate the tornadoes as far as structures. There might be a little shed out in a farm, or maybe a little windmill, or some type of a silo or something. But when there's not much reported damage, these are supposed to be rated as EF0s, okay? Sometimes some National Weather Service offices will use EFU for unknown for rating those types. So those are EF0 tornadoes. All right, let's get into EF1s. Here you go. Moderate damage, roofs severely damaged, okay, and homes heavily damaged, mobile homes heavily damaged or overturned. So here you're looking at a lot of damage to the roof. The guttering's ripped off. You're also seeing the loss of some of the windows, and exterior doors can be blown out. So this is an EF1 damage there, and you're starting to see more trees damaged here. Some trees snapped, larger limbs, and even some trees overturned. All right, EF2 damage. Now it's getting pretty rough here. We have considerable damage. Roofs are torn off of well-constructed houses, and that's the case here. You've got a framed house, okay? It's not a mobile home. It's a framed house. Set up, pretty stable house here. Roof is ripped off. Foundations of framed homes can shift a little bit. If you've got a crawl space, maybe that home shifts off that crawl space a little bit, or slides on that concrete pad a bit, all right? Mobile homes can be completely destroyed. All right, large trees snapped and uprooted. Light objects start to become missiles at this point. So now you've got these little sticks, branches, rocks, whatever the winds pick up, whipping around, and they become like missiles. Cars can be lifted off the ground, even with this EF2. Very, very strong, and they're getting stronger as we take a look at an EF3. All right, EF3, this is something to see here, and it's important. We're going to talk about tornado safety. We're going to do that coming up maybe a little bit tomorrow when we really break down tornadoes, how they form. That's going to be my topic tomorrow. But take a look at this. Here you have a well-built home, all right, and there's severe damage here. Roof gone. All right, some walls torn off, okay, the exterior walls, and you see still parts of the house are intact. Talk about safest places to go. Interior rooms with no windows, okay? This room here below the stairs, the safest place. So while the outside and the top of the house were destroyed, that interior room on the lowest level still standing up there. Very important to note that, okay? You have trees in forested areas. They're uprooted. Cars can be lifted and thrown. Important to note, here we have an EF3, all right? Back in 2008, there was a tornado that hit Suffolk. And I'll show you the picture here. This was taken by one of our colleagues. We love this guy very much. He was a photographer. We lost him after a battle to cancer. Ryan Beard took this picture from out in Suffolk. We had this EF3 tornado, and I was out there after it had come through, like immediately following, and I got out to one of the little satellite offices for Obacy Hospital out there in Suffolk, and there's actually a truck that had been picked up and stuck into the side of a building. I was trying to see if I could find that picture. I couldn't. But it shows, when we talk about cars lifted and thrown, that happens, and you can see the damage here to the homes out in Suffolk. This was an EF3, and it was really something. We don't typically get tornadoes this strong here in Hampton Roads in southeast Virginia. You get these more frequently back in the Midwest, parts of the deep South, but right along the coast, you don't typically see the EF3s, EF4s, EF5s. But this is one of the images taken from the Suffolk tornado, and it was something else. When I got out there was a strip mall. And inside the strip mall, there was actually one of the cars from a parking lot had been picked up and thrown into the roof, and it was hanging from the rafters. I mean, it's incredible, some of the damage that you get with some of these tornadoes. So that one really hit close to home. Now, this is, again, another image from the National Weather Service in St. Louis they used for education. I believe this was a Bridgeton tornado, again, a part of St. Louis in the city and county area right there in St. Louis. You can see some big homes still intact, but a lot of damage to some of those, while other homes completely destroyed. Here you go, EF4, devastating damage. Well-constructed and whole frame houses can be completely destroyed, as you see with that one. All right, some can be leveled or swept away. Cars and other large objects can be thrown. And again, small missiles are generated. So you've got more of these boards and construction pieces flying around. You've got things sticking into the sides of buildings. I mean, it's incredible, some of the damage that can occur with an EF4. And then we get to that highest level, up over 200-mile-per-hour winds, the EF5, incredible damage. And this is a look at some of the damage from Joplin, Missouri. Again, EF5, well-built frame homes destroyed, foundations swept clean and clear of the debris. Look at this. This house was completely swept off its foundation. It's just unbelievable. Even concrete structures reinforced with steel can be either destroyed or they can be deformed. It's just amazing, all right? Tall buildings collapse, all right? And we have cars and trucks, even trains can be toppled and thrown. Some cars and trucks can be thrown up to a mile away. So it's incredible the amount of damage that these tornadoes can do. You see it right there, and it's just heartbreaking, okay? But this is what can happen, and this is how we rate those tornadoes. Look at the ground damage here. This, again, taken by the Air Force, and this was out around Moore, Oklahoma. So you can see, again, just a pile of rubble. From the air, you can see the start and stop points a lot. You can see those clear boundaries on the ground. It's just utter chaos and devastation. Really, really incredible to see. Now, hopefully you enjoy these weather talks and these weather schools. We're going to keep doing them for you every morning, 9:15. Shout out to Rochelle Peart. She's done an awesome job helping pull together some of these facts. Like I said, she stumped me on the trivia this morning, Rochelle. Doesn't happen often, but she got me. All right, that's how you can reach Rochelle, Facebook, Instagram, and Twitter. Those are my contacts, again, through social media. We're going to keep doing these. Hopefully you guys enjoy them. And again, if we could share these and get these out in front of more and more students, that's the idea. We want to bring as many students to our weather school as possible and give parents a little break where you know your kids are learning something. Hopefully they're having some fun, and we're going to keep doing these for a while. All right, tomorrow we're going to talk about tornadoes. We're going to get into lightning and thunder and other weather safety coming up next week. So we've got some more stuff planned out over the coming days. Hopefully you guys like these. Thank you so much for your interactions, your thumbs up, your hearts, your loves, all that kind of stuff. And let me remind you, if you ever miss a weather school and you want to go back and look at it, sometimes they're harder to go back and find on Facebook. We've got them all posted on our YouTube channel, 13 News Now. The YouTube channel there. You can check it out if you look for Weather School. All right, again, I'm meteorologist Craig Muller. Thank you guys so much for joining. Tomorrow, tornadoes. You don't want to miss that one.